Okay, so piece 3, when x is 6, y is 3. Okay, let's go on to when x is 7. Lena, when x is 7, y is what on piece 3? Shh. Lena? Also 3. Oh, man. How about Emma H? When x is 8, what's output?
3.
Always 3 for the third piece. All right, let's use your straight edge or an ID or a ruler. Go grab one if you wish.
Wait, why is it 3?
Yeah. Why is it 3?
Because the y is 3. Because that's what it says.
Hannah right here. This is piece 3. Right?
Oh, so you're just changing the.
Because these have x's. That's what the heights are changing. This doesn't have any x's. So it doesn't matter what you plug
So it
in.
can't be less than 3.
It can never be anything but
3. So x has to be more than 6.
right. Or we can have 6 if we need an open circle. But y is always constant at 3. It can't be anything because there's no x in it. You can't change.
Yeah, no, it's open circle because it can't.
You're right, because it's not an equal to. So these are both open circles. So is these two are both closed because they both have equal to. Okay? All right, let's plot those dots. Here we go. 6, I'm going to plot an open dot at 3, so count correctly. 2, 4, 6. Well, what? There's a closed dot already there. Is it okay to have? Yes, it's okay. Guys, right now, those two are just overlapping. Feel free to fill in the hole. Okay. Then at 7, I also have 3. At 8, I also have 3. So I'm just going to make, what kind of line is that? A straight horizontal line. All right. Do I make an arrow? Yes, you have to. It's array for that one. Okay. So that's how we graph out the piecewise. And again, I'm going to go very slowly so we know. So the next piece, yes. I'm sorry, one more time, Brandon?
I don't understand. I got piece 1.
The piece one?
Yeah.
Sure.
Piece 1. Like for piece 3, you're talking about how like we didn't have like an X or Y thing here or something.
Mm-hmm.
So like Y was 3, I don't understand. Like just basically don't get anything.
Well, that's not really a question.
Why? Well, how'd you get piece 1?
What is your piece 1? Can you tell me that first?
What do you mean by what is it?
What is it that we're
2x plus 1.
2x plus 1, yep. If there's a comma, so read it to me, if.
If x is less than
Perfect. So Brandon, great. That's your piece 1, okay? Can you see how this one says x is less than -2? Right there, the highlighted piece.
yeah.
Give me a value, Brandon, that says x is a less than -2 value. Great. What else? Great. What else? Okay. Those are all very great value for less than. If I said -2.5, is that still true? If I say -2.1, is that still okay? If I say -2.0000001, is that still okay? So where would I start if I don't have where would you start? Like what would be an okay value to be less than 2, that's closest to 2 as possible? Right. So what happens in mathematics, Brandon? We pick a value right at -2, right? It says here less than -2, but we pick that value anyway. Knowing that, I'm going to use what kind of circle? To represent what in mathematics? Talk to your team. Why do we? Come back to me with an answer. Why do we use an open circles in mathematics? Team, talk it out with Brandon.
It can start there, but it can't go.
Right. So what that's saying, Brandon, is I'm going to pick a value at -2 and see how together we did an open circle last week. I can pick -2.5, -2.1, -2.01, as close to 2 as possible, but just never ever negative, close to negative 2 as possible, which is never ever on negative 2. That's why the open circle is chosen. So that's why the first piece, we pick negative 2, and guess what we wrote next to it? And then we pick 2 more values that you said it was okay.
Wait, so when you like plot the open circle, that after you get your negative?
It's that what?
Like, when did you plot the open circle? Like, how do you know where to plot the circle? Did you just like plot a negative 2?
No, no. What did we do here? What did we create?
Equation?
No, I did not create an equation. I created a what? We create a T chart. What did we use in the T chart besides the inputs? What number did we use? Where did this come from? That first piece you said. Every time I see an X, you plug in what? The X that you have chosen. Or in this case, we together have chosen last week.
Wait, so if you chose negative 3, negative 4, negative 5, would that be wrong?
That would partially right. Because you still need to have a starting point. Remember, our starting point is technically somewhere near negative 2. That's why it's always a good idea to pick negative 2 but have an open circle. What's your second piece in this piecewise? Read it to me.
My second piece?
Uh-huh.
So I just read the whole second piece here? Negative 1/2 x plus 6.
Yeah.
As if negative 2 is less than or equal to x less than.
Great. So notice how that one has a starting piece and it ends. Right? It doesn't go one way like this piece, and it doesn't go one way like that piece. So this is what we call a segment. A segment means you have a starting point and you have an ending point. Both of these endpoints will be closed circles or open circles.
Open. No, they're going to be closed.
Yes, that's the difference between that and that.
So there's a line of there.
You're right. And notice how both starting points we picked. Both endpoint we also picked. And we picked a third point which is in the middle. So we can make sure our line is straight. Then where did these things right here, Brandon, come from?
Just by plugging in.
You're right, by plugging what piece you have said. Does that make sense so far? Same thing for the third piece. What value should we pick on the third piece? Starting at 6, but know that it has to be an
open circle.
Right. And because we want a straight line, guess what we do? We take 2 more points. But what's the difference in this piece, Brandon, and the first two pieces? Right, because there's no X here to plug in. Because Y is always at 3.
Sorry, how'd you know to start for 1 and 2? Or no, for 2 and 3.
You just told me.
Huh?
You just told me how we started.
What about for 3? Do you go off of the X or do you like?
Well, that's your input. X is your input. Input is the piece that you can pick. But once you have chosen X, you cannot pick Y because Y is dependent on what? X. That's why Y is called dependent. Hannah?
Is the first equation, is that always
The first piece.
The first piece is not always going to be Y or X, and then after the.
This is how we get Y, by plugging into here.
But I'm saying, if you flip, where we use that for X and Y?
No.
So it's always going to
X
be.
is right over here.
But I'm saying it's never going to be flipped or the first.
No. It's always written in that way.
And that way we're the value of X is right.
Correct. That's why this is if X is.
Okay.
If X is. If X is. X is always over here. Okay, talk to your team, and then you can come back and explain to me. Where's your notes? Okay, then how would that help you? If you don't have your notes, and you don't have the right to ask.
Okay.
All right. Anyone else? We will stay here at break time because I do have to finish all of our notes today. I appreciate
good questions if you're paying attention. But if you are wasting class time, then I don't appreciate that, and we will stay here and finish our notes. Okay, anyone else with questions? Yes.
I have just one quick question.
Yeah.
The third piece, figuring out where to start it, did you get that from the second equation that was given?
This right here?
Yeah. Did you
No,
get it
the
from
third
X
piece,
is
Grace,
greater
has to be from the third.
Oh, no, yes, I mean the second equation in the third piece.
Right here?
Yeah, x is greater than 6.
Uh-huh.
Is that 6 where you start?
Correct.
Okay.
But because this doesn't have an equal sign, that's why we have an open circle. Same thing with this. Notice how we became -2 here as well?
Yeah.
Because there's not an equal here, that's why we also wrote open.
Okay.
Anyone else that took notes that still did not get piece 1, piece 2, piece 3? Now we're going to answer all of these components over here. The first component says, is this a function? Now go back and read your definition of functions. What is the definition of a function? Brayden, take out your piece of blank paper and copy notes. Okay, Roger, what was the function there?
Yes. Yeah.
Okay, so by definition of a function, okay, just read it to me. You don't have to look. Joe, did you write down definition of function?
A function is a relation from a set of inputs to a set of outputs. Each input is related to exactly one output.
And there's a test. What kind of test? That's one of the important ones. Yes, it has to pass a vertical line test. Thanks, Emma. Okay, so let's draw a vertical line test. I'm going to draw a line, first line over here. How many times does it intersect? So does it pass on that side? Keep on going. Does that say okay? If I draw a line right here, how many times would that intersect? Is it really twice? It's intersecting once here. Can we agree?
Yes.
Keep on going.
Twice.
But
Actually, no,
it's an open circle. What does it really mean in mathematics when you see an open circle? It's not even there. It's not even there. It's somewhere very, very close. But is it right on -2?
Yes.
No. So even if I make a vertical line right here, how many times did it intersect? Technically, once. Once. It did cross over 2 dots, but one of it is what? Open. It's not there if it's open. Then keep on going. Is it ever intersecting more than once? No. So is this a function? Yes. Now, we're going to go to, is it a one-to-one function? Okay. What kind of test must it pass if it's a one-to-one function? Yes, we're going to draw multiple horizontal lines. Is this first one going to pass? Yes. Is this first one going to pass?
Yes.
I'm sorry, you said yes, I wrote no. My bad. Sorry, it's yes. Sorry, I meant I was ahead to this one. Is it a one-to-one? So, first horizontal line. Yes, this one? Yes. Technically, this is nothing. What's happened if I draw a horizontal line? Infinitely many times that it did intersect. So is this a one-to-one function?
No.
It's not a one-to-one function. Okay. Then we're going to say, is it continuous? Okay. So by definition of continuous, is this continuous?
No.
Can you graph? Can you graph the function from beginning to end without lifting up your pencil? No, so it's not continuous. Okay, now let's talk about the domain. The domain is describing what? All x's. No? Okay. The domain is describing all x's. You always want to start on the negative side. Will you have -1,000, -1,000,000 x over here at some point? Because of what? How do you know? The zero. You're going to have a negative infinity. I'm going to keep on going to the x. Do I have a negative 2 for x?
No.
Not here, but right there. So do I have a negative 2?
Yeah.
Keep on going. Is it ever going to stop? No. So what's your domain? All real numbers. Okay. Now we're going to go to the range. Again, the range is describing all y's. Okay, let's start always negative. Would it have negative 1,000 down below some y values?
Yes.
All the way keep going. Negative, negative, negative. Do I have anything here? A circle. So a circle means do you have it or not? No. Do you have negative 1 for y? Negative 2? 1? Do you have anything here for y? No. So we're going to start negative infinity. Go all, and when does it stop? Negative 3. I'm going to hold on and I'm going to write some notation, which I'm going to introduce to you right now. We are going to start negative infinity. So we're going to start negative infinity. We're going to take a little break at negative 3. Can you see that? Okay, a little break. Now I'm going to use parentheses. The reason we're going to use parentheses here, because at negative 3 on y, what kind of circle was it? Open. So technically, was it even there? No. That means it's not inclusive. Not inclusive means it's not even there. Okay. Then, do we stop right there for y, or did it pick up another location? It did. Okay, it takes a little break. It takes a little break right here. And then where does it start picking up? At positive 3. And keep on going to what? 7. Okay. So, but here's another notation that I will introduce. Okay. And it picks up at quantity here, positive 3 to 7. Can you see these are square brackets? Now, let's look at the different things. This parentheses bracket here and the square bracket. The square bracket, meaning that it is inclusive. Does the y value exist at positive 3? Does it exist at positive 7? Yeah. So the square bracket means, is it inclusive or not inclusive? Inclusive. Okay. So these square bracket class mean they are included or inclusive. Included and inclusive are about the same. So if it is okay, then use a square bracket. Now the infinity symbol, you always have to use the non-inclusive, which is the parentheses. Because why? Why do we use non-inclusive parentheses symbol for infinities? The positive infinity, the negative infinity. Why do we use parentheses? Not because it's, Grace? Right, you cannot determine an exact number for infinity. That's why it's not a square bracket, okay? Now, we have 3 more components for this one. Find f of 2. Find f of 2. Raise your hand and you can tell me what we do with this back then. What did we do with this? Plug in 2 for x. But how many pieces do we have? How do I know which piece?
Just pick one.
Nope.
Do all of them.
Nope.
Don't do all of them.
You have to first find which of the 3 pieces contains what? 2 for x. That's fine. Is 2 over here? Is 2 over here?
Yeah.
Perfect. I have 2 pieces over here. Which one of those 2 pieces contain a positive 2? Piece number 2. Even look at this. Does this piece contain positive 2?
No.
Does this one?
Yeah.
Yes, because positive 2 is in between negative 2 and 6. All right. So x is positive 2. I'm going to write piece 2 next to it. Okay. Piece 2 next to it. And then every time you see an x, guess what you do?
Put a 2 there.
All right. So f of 2 means What is piece 2? What do we write? Negative half times positive 2 plus 6. So f of 2, what's negative half times 2? Negative 1 plus 6. 5. So f of 2 is 5. Okay. Now similarly, we're going to find f of 8. Now I want you to think in your team, discuss which one of the 3 pieces we're going to pick. So in your team. Then I'm going to shuffle your cards and call it.
What I did was like,
Okay. So Kennedy, which of the 3 pieces are we going to use for f of 8? The third one you said? Okay. Do you guys agree? Yeah. Look, this one doesn't have 8. This one ends at 6. This one's greater than that. So that's definitely right. So I'm going to write third piece on it because third piece I used red. So I'll use piece 3, okay? So f of 8, let's plug it in. Well, is there anything to plug in? No. Y is always 3. So guess what we just write? Just 3. F of 8 is 3. By the way, sometimes you can even look at your chart and see what the answer is. Okay. Now, let's look at the last component. Find what? X. If f of x is negative 9, can someone raise your hand and give me a variable that I can sometimes substitute for f of x? What is a variable that I can substitute at times for f of x? Y. F of x is just a function of x, which also means, I'm going to write next to it, aka y equals negative 9. So find x. All right. Again, we got to go back to the 3 pieces. Which one of those pieces would have negative 9 for what, by the way? X or y? X or y? Not x. X, y. All right. Does piece 1 have negative 9? Yeah, it's right here. I just have to tell you where that is for x. So what do we do in that case? Do we plug in negative 9 for x or y? Y. Okay. So we are going to plug in negative 9. Negative 9 equals, what does it equal? 2x plus 1. Let's solve for x really quickly. Joe, help me. What's the first step in solving for x?
Subtract 1.
Good. So subtract 1 from both sides. I'm out of space. I'm going to move it over really quickly. So divide by 2. Thank you. So divide by 2. So Joe, what was x?
X is negative.
Good. So when y is negative 9, x is at negative 5. So go ahead and copy it all down. I'm going to pinch it in really quickly. So all the So here are some rules, or not really rules, I would say, some suggestions for graphing piecewise functions. So can you help me read, Roger, number 1, please?
Determine how many pieces there are based on the number of equations.
Perfect. Can you please, Hannah, help me read number 2?
Determine what shape is segment or ray going which direction.
Good. Okay, so decide on, hey, is that a segment? Is that a ray? Go for it, Joe. If that one doesn't work well, Joe, there's another one in that corner. Okay. McKenna, can you help me read 3, please? Perfect. So if it's an open circle, is that inclusive or exclusive? Exclusive. Open circle means exclusive. Open, exclusive. Okay. If it is a closed circle, it means what? inclusive. Delaney, can you help me read 4, please?
Graph each equation over its specific domain.
Right. Very good. Chance, can you can you help me read hit the keyboard for me? Thank you. Thank you. All right, Chance, help me read the next one.
For 5,
Yes.
double check that what you have graphed is a function vertical line test.
Yeah, so it has to pass a vertical line test. And James, can you help me read 6, please?
Find all the information asked for about the function.
Perfect. Okay, answer all the questions. Let's do 2, and then you have a check for you for 3. Okay, can you just help me read this one? Remember, reading is one of the major part that's already confusing. So Arista, can you just help me read the one function?
2x plus 7.
F of x is
2 of x plus 7 if x is less than -6.
and read the entire function.
Oh, and negative a half of x minus 4 if x is greater than or equal to -6.
Perfect. Aaron, how many pieces do we have?
2,
Perfect. How many function do we have on example 2?
1.
One f of x means one function. All right, let's make a table for piece 1 and piece 2. Okay, now I want in your team to decide what's for piece 1. What's our starting point, and if it's going to be an open circle or a closed in your team. So once you've decided, okay. So Victoria, piece 1, what is your starting input? Good. Open circle or close? Yes, very good. Open circle, very, very good. Okay. Now let's plug it in. Grace, what are we going to plug that into?
2x plus 7.
Yep, so 2x, so that means it's 2 times -6 plus 7. Brandon C, what is that output?
Which one again?
The one I'm writing.
You want me to write down the equation?
Nope, I just want you to give me the output. Talk to your team. If you've
I got it, don't worry. That would be
negative 5. Give me another input, Brandon, for this first piece.
another one.
Yeah, I need 3 total.
Wait for piece 2.
Nope, so on piece 1.
-7.
Great, one more. Perfect. Go ahead and plug it in for me, Brandon, and give me both outputs. Okay, throw it at me.
Alright, so the one for -7, right?
Mhm.
That's gonna be -7.
-7, perfect.
And then the one for -8 will be -9.
Okay, let's plot it out, guys. Thank you, Brandon. All right, -6, I have to count very slowly. A -6, 2, 4, 6, go down 2, 4, 5. You said open circle or close? It's an open one, you're right. -7, go down to -7. -8 is now -9. It's right there. Is it a segment? Is it a ray? Is it a line? It's not a segment, but it's a ray. A ray means there's an arrow going one direction. Okay. That's piece number 1. Piece number 2. So in teams, talk about the starting point for piece 2. And then I'm going to call one of us. And then decide if it's open circle or closed as well, okay? All right, Dylan H. What's your starting input, dear?
-6.
Open or closed, dear? Open circle or close? Close. Excellent. Okay, let's plug it in. we're going to plug it into negative 1/2 times negative 6 minus 4. So class, what would that be? Negative 7 again? Are you sure? What's negative 1/2 times negative 6? Negative 1. Oh, positive. I mean, your final answer. I think you were there. Negative 1/2 times negative 6 is a positive 3. Minus 4 is now a negative 1. So I think you were ahead of us on that one. Give me another input. Remember, I want 3 total. Okay, so Hunter, give me one more input.
Negative 4.
Negative 4. Beautiful. And you know what I love? What's my favorite number? 0. Is 0 bigger than negative 6, by the way? Yes, it qualifies. Okay, so I'll plug in negative 4 and Emma P. Give me the output when you are ready. Negative 2. Someone check that for me. Yeah? Okay. And then 1 is 0. What's your output? Negative 4. I love 0, right? Okay, let's put it in. Negative 6, go up to here. And earlier, I was told by the lens to be a closed dot. So negative 6, comma, negative 1. Negative 4, 2, 4, and negative 2. Open or close? Still close, right? And then 0, negative 4. Is this a segment array or just a bunch of dots? It's going to be a array going that way. Okay, we got 2 pieces. Let's identify all of the components here. Miss Amanda, is this a function? Yes. Guys, the only issue I can probably see is this, right? But one of those dots is what? So is it even there? No, so it's definitely a function. Very good. It's yes. Is it 1-to-1? Is it 1-to-1 class? What kind of test are we going to do? Okay, I'm going to draw it right here. How many times is it going to hit my horizontal line test? Twice. Twice. 1 here, 1 there. So is that a 1-to-1 function? No, it's not a 1-to-1 function. 1-to-1? No. Is it continuous, my dear Hope? No. Okay. We're going to talk about the domain very cautiously. What is the domain, Daniel? Let's start from negative, okay? We're going to have negative over here somewhere. Keep on going. Do I have x value here? It's an open circle, but yeah, there's a closed right above it. So do I have an x value here? Yeah. And then will I have x value all the way over here? Yeah. So what's your domain? If you just yes to all those questions, what's your domain? Why? Tell me why.
I don't know.
Okay, talk to your team. Tell me why. What's the domain asking? Domain is asking.
Good morning, Oilers. Your morning announcement. Please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Class is engaged by your opening dance. Permission is not required only if you're bringing it off campus.
So Daniel, think about what I asked. What is the domain to asking me?
No tickets will be sold at the door this year.
Now, we have the results for the class president election. Your senior class president is Ella Thomas. Your junior class president is Edith Henry. Your sophomore class president is James Moore. And your freshman class president is Mason Manzo. Congratulations. Speaking of elections, we're also happy to announce this year's homecoming court. Freshman prince and princess are Kate Hart and Mason Manzo. Sophomore prince and princess are Max Polizzi and Rachel Latorno. Junior prince and princess are James Perez and Katie Park. Your nominations for Queen are Taylor Wright, Jane Fay, Megan Gibbons, Vanessa Wong, and Ella Thomas. Your nominations for Queen are Dylon Tu, Joaquin Browning, Sam Williams, Henry Lyman, and Jared Manzo. If you're nominated for Queen or King, please go to J2 for a mandatory meeting at lunch. Remember, you can vote for your King/Queen by checking your student email for the ballot on Google Forms. Voting will end this Friday at 4 p.m., so make sure to exercise your right to vote. The winners will be announced at our homecoming football game on Friday at 7 p.m. The game is a whiteout and there will be color packets thrown, so be prepared. Can't wait to see you all there.
This is your last week to turn in your school ID for no 5th and no 6th period sticker. After this week, the supervision department will not be accepting schedules to leave campus at lunch. Please be responsible and turn in your ID card to a receptionist as soon as possible. The APA Orchestra Department's Fall Chamber Music Recital is this Thursday, October 11th at 6 p.m. in the Music Building. Come listen to some great music performed live by our amazing APA orchestral musicians. Students admission is free.
Are you interested in auditioning or interviewing to be an APA for the 2019 school year? If your answer is yes, you should consider attending the annual APA Open House on Saturday, October 20th. You can apply from the receptionist desk or from the APA office. APA says, hop on over to the APA office on getting a $10 student ticket to see Mary Poppins or Beetle 68. Get your student tickets from the APA office located in the music store.
Hey Oilers, are you interested in traveling abroad this summer? If so, the French department will be traveling to Paris, London, and Cannes on June 24th to July 5th, 2019 for their annual summer journey. This trip is open to all APA students at HHS and is truly a trip of a lifetime. If you are interested in the opportunity, please visit Madam Dunn